Statistics has two branches, descriptive and inferential. Inferential means drawing information about a population using sample values. And statistical inference has two branches, estimation and testing. Testing is a problem of decision making, of accepting or rejecting a hypothesis or an assumption using sample values. Again, it has two branches, large samples and small samples. Here we are discussing a large sample test procedure for the equality of two population proportion of attributes, that is based on a qualitative data. Test for equality of population proportions. It is a test for attributes to population proportion where attribute is a quality characteristic. Testing of hypothesis is used for decision making. We have two situations. One, test for single proportion and test for equality of two population proportions. Here our objective is to compare two populations with their quality characteristics. This is termed as proportion of attributes. Let P1 and P2 be the proportion of attributes in two populations with a quality characteristic. The population characteristics are always parameters, unknown constants. Then we have to compare them or we have to measure them in terms of statistical data or statistic. The data is from samples drawn from the population. Here P1 and P2 are the sample proportion of attributes with respect to two samples of sizes N1 and N2 drawn from the two populations respectively. That is for studying population, we use samples. That is the branch of statistical inference, information about a population from samples. Then P1 equal to x1 by N1 and P2 is equal to x2 by N2. They are the sample proportions. x1 and x2 are the number of units possessing the attributes in the two samples respectively. So this is the P1 and P2 are the sample proportions. P1 and P2 is the sample proportions drawn from samples. They are used for drawing information about the population. The procedure at first state null hypothesis. H0 is that P1 is equal to P2, that the two populations are having same proportion of attributes and it is taken as P. H0 is that P1 is equal to P2, it is taken as P where the two populations are having same proportion of attributes, and we perform the test in terms of sample information. Then this H0 is stated as or interpreted as there is no significant difference between the sample proportions. H0, P1 is equal to P2, that the population proportions are equal, and we are performing that test in terms of sample data. So H0 is stated as there is no significant difference between sample proportions. And H1, as we know, depending on the situation, P1 is not equal to P2, two-tailed. Or P1 is more than P2 or P1 is less than P2, one-tailed. Then how will you take decision in terms of a test statistic? A statistic used for testing. Its form is difference by standard error. Here it is P1 minus P2 by square root of PQ into 1 by N plus 1 by N2. That follows standard normal test. Therefore, this is a large sample test. This is a normal test. Decision is based on the normal probability law. Usually, H0 P1 is equal to P2 is equal to P. Usually, this value of P. Usually, P is unknown. Therefore, result is stated as P1 minus P2 by root of P estimate into Q estimate into 1 by N1 plus 1 by N2. That follows N01. Again, standard normal. So, what is P estimate? That is the population proportion P is unknown, not known. Hence, we use its estimate. That is x1 plus x2 by N plus N2. Sample data. And Q estimate is equal to its complementary 1 minus P estimate. Now we are moving to decision. That is, either accept a hypothesis, reject a hypothesis, H0 using the calculated values of Z and critical values of Z at level of significance alpha. Alpha is the level of significance. Then accept H0 if the absolute value of Z is less than Z alpha by 2 for a two-tailed test. And accept H0 if absolute Z is less than Z alpha for one-tailed test. And at alpha equal to 5%, Z alpha by 2 is 1.96 and Z alpha is 1.645. Usually, we use 5% level of significance, and these values are available from the area property of standard normal distribution, which has been tabulated. That is, these values are available from tables of standard normal distribution. This is the statistical procedure of testing equality of two population proportion of attributes. A problem is given as, in a random sample of 600 and 1000 people in a town, 400 and 600 people are found to be tea consumers. Do the data indicate that populations are significantly different in proportion of tea consumers at alpha equal to 5%? So it's a problem of a quality characteristic. So we apply the test for equality of proportions since there are two samples or two populations. So it's a problem of equality of population proportions. The consumption of tea, that's a quality characteristic. It is given that out of 600, 400 are consumers. Therefore, P1 is equal to X1 by N1. That is 400 by 600. And P2 is equal to 600 by 1000. That is X2 by N2. This is equal to, they are the sample proportions. N1 and N2 are sample sizes. X1 and X2 are the number of units possessing the attributes in the sample. At first, we have to state the null hypothesis. Our problem is test whether there is a significant difference in the proportion of tea consumers. H0 is always stated as there is no difference, there is no significant difference, or the two populations are identical with respect to the proportion of tea consumers. The population proportions, proportions are measured or compared with respect to sample values. Hence, the H0 is also stated as there is no significant difference between sample proportions and H1. P1 is not equal to P2. We have to test whether there is a difference or not. Therefore, P1 is not equal to P2. That's a case of two-tailed test. The test statistic Z is equal to P1 minus P2 by root of P estimate into Q estimate into 1 by N1 plus 1 by N2. That follows standard normal distribution. P estimate, that is the combined population proportion, X1 plus X2 by N1 plus N2 equal to 400 plus 600 by 600 plus 1000. That is on computation 0.625. Then Q estimate is complementary 1 minus 0.625 is 0.375. Then the calculated value of Z is 0.67 minus 0.6 by root of 0.625 into 0.375 into 1 by 600 plus 1 by 1000, that is on simplification 2.8 approximately. Then absolute Z is 2.8, that is the absolute difference. The conclusion, which is more than the critical value of 1.96 at alpha equal to 5%. Therefore, our conclusion is reject H0. That is, the two samples differ significantly. Or with respect to this problem, the proportion of tea consumers in the two samples are different significantly. Another problem is given. In a year, there are 956 births in a town, of which 52.5% were males. While in towns A and P combined, this proportion in a total of 1406 births was 0.496. Is there any significant difference in the proportion of male births in the two towns? This problem has some mathematical properties, needs some mathematical computations. This is not a direct problem. We need some mathematical computations. At first we look into the problem, what informations are provided. Given that n1 equal to 956, a sample of 956, and a total of, that is n1 plus n2 is 1406. Therefore, the difference 1406 minus 956 is 450. So here a computation is needed. P1, proportion of males in town A, 52.5 by 100, that is 52.5%. That is 0.525, that is P1. P1 is given. Then another estimate P is given. P is 0.496. We know that P1 is equal to x1 by n1. Therefore, x1 is equal to n1 P1. P2 equal to x2 by n2. Therefore, x2 is n2 P2. Then P estimate is x1 plus x2 by n1 plus n2. Here we use its mathematical interpretation. That is n1 P1 plus n2 P2 by n plus n2. That is 0.496. That is given. That is given. So we need the value of P2, which is to be derived from the given information. P1 is 0.525. P estimate is 0.496. Then we have to calculate Q estimate. That is by theory, 1 minus P estimate, 1 minus 0.496 is 0.504. And we know that P estimate is n1 P1 plus n2 P2 by n1 plus n2, that is 0.496. Then available values are substituted in this 956 into 0.525 plus 450 into P2. We have to calculate P2 by 1406. As on simplification, P2 is equal to 1406 into 0.496 minus 956 into 0.525 divided by 450, that is 0.434. Therefore, P1 is 0.525, P2 is 0.434, N1 is 956, N2 is 450. All figures are calculated. Then we state null hypothesis. The question is whether there is any significant difference in the proportion of male births in two towns A and B. H0 is always stated as there is no significant difference. H0 is that P1 is equal to P2. The question is whether there is any significant difference. Therefore, H1 is there is some significant difference. That is P1 is not equal to P2. So that is a case of two-tailed test. The test statistic Z is equal to P1 minus P2 by root of P estimate into Q estimate into 1 by N1 plus 1 by N2. That follows standard normal distribution. That is, for drawing decision, we use the property of standard normal distribution since it is a large sample test. Then the numerical value of Z is 0.525 minus 0.434 by root of 0.496 into 0.504 into 1 by 956 plus 1 by 450. That is 3.37 on computation. Z is 3.37. Then the conclusion. The absolute value of 3.37, which is greater than 1.96 at alpha equal to 5%, unless otherwise stated, we use 5% level of significance. Hence, the conclusion is reject H0. Reject H0. Hence, we accept our alternative hypothesis. That is, P1 is not equal to P2. That is, there is significant difference in the proportion of male births and in towns A and B. That is our conclusion. We reject H0 and accept H1. Here is another problem. A machine puts out 20 imperfect items in a sample of 500. After the machine has overhauled, it puts out 5 imperfect items in a batch of 150 items. Has the machine improved after overhauling? Overhauling means repair. This is a problem of application category, different from the routine nature. There is no question about significant difference or equality. Question is, has the machine improved? Has the machine improved because of the repairing? So we are using our given data. N1 is 500 and X1 20. Therefore, ratio of imperfect articles before overhauling is 20 by 500. That is 0.04. After overhauling, P2 is 5 out of 150. P2 is 0.03. Our question is there any change? Has the machine improved, not changed? It is improved. So H0, there is no significant difference in the proportion of imperfect items before and after. There is no significant difference before and after overhauling. That is, P1 is equal to P2. Before and after, the proportional defectives are same. That is, the machine has not improved. The machine has not improved. There is no change in the performance. So what about H1 from this point? Has not improved. So H1 is the machine has improved. If the proportion of defectives is less after overhauling, then the machine has improved. Therefore, H1 is taken as the machine has improved. That is, P2 is less than P1 or P1 is more than P2. The proportion of defectives, imperfect items before overhauling is more. Now it is less. So the machine has improved. So our interest lies this here. So this is a problem of applied category. Coming to the final stage, the test statistic is Z is equal to P1 minus P2 by root of P estimate, Q estimate into 1 by N1 plus 1 by N2. That follows standard normal distribution. Then P estimate X1 plus X2 by N1 plus N2, 20 plus 5 by 500 plus 150. That is 25 by 650. That is 0.038. Therefore, Q estimate is 1 minus P estimate. That is 0.962. That is 1 minus P estimate. Then computation of Z. Z is 0.04 minus 0.033 by 0.038 into 0.962 divided by 500 plus 1 by 50. Our simplification, that is approximately 0.4. Then absolute value of Z is 0.4, which is less than 1.645. That is a critical value at alpha equal to 5% for one tail. Since calculated value is less than the treble value, we accept our null hypothesis. So what about the conclusion in this special type of problem? The machine has not improved. The ratio of imperfect articles before and after overhauling are same. That is, accept H0. The machine has not improved after overhauling. The illustration about the test for equality of two population proportions has been completed. Population proportion of attributes is a qualitative test and it is based on large samples. It is used for comparing the qualitative aspect of two population. Now we completed the discussion on that topic.